Okay, so hello everyone. Hello to y'all. This is the 5th Godot workshop. We're going to be working on these things: making enemies, introduction to singletons, and this is wrong. We're going to be doing audio, not UI. I'll fix that. Anyway, is there any questions before we begin? We're going to be using C# for this workshop. However, there is also a GD script version. So if that's your thing, if you're watching this on Twitch or YouTube, you can look at that. It's on the VGDC website. So, again, any questions before we begin? Okay, we will begin. So, the first thing that we're going to be doing is we're going to be talking about enemies. So, when we think about wanting an enemy, we pretty much want it to interact with the world physically and interact with the player. We also want it to have, some sort of visual component, maybe some animation stuff. And what that makes me think of is a prefab. And so we're just going to be making a new scene, and we want a custom node because we're making a prefab right off the bat. So for this enemy prefab, we need to kind of think of what our root node is going to be. And we know we want it to be interacting with the world physically, so that leaves us with two-dimensional collision objects. So if we look at our collision objects, our little selection, we have a couple of options. We have, an area 2D, a kinematic body 2D, a rigid body 2D, and a static body 2D. So in order to choose one of these, we have to, think about what we want. We want it to move, so it can't be an area nor a static body 2D, because both of those mostly imply that it can't move. The two that can move are rigid body and kinematic body. We could use either one of them, but setting up a kinematic body 2D to move is a little bit more complicated, and it's not really something we want to mess with right now. So we're going to be using rigid body 2D. This means it's going to have simplistic functions. It's going to have gravity. It'll interact with the world, and so on and so forth. And that sounds pretty good. So now we have that as our root. Of course, we need a little bit of a collider. So we can just search collision shape. Maybe actually search collision shape 2D. I think a square is going to be fine for what we're doing. And then we also need a sprite. And this is just going to be under the rigid body 2D. So depending on what you want, if you have animations in different pictures, you'll want an animated sprite. If you have an animation in the same picture, which is to say it's a sprite sheet, then you want a sprite with an animation controller. But for now, we're just going to use sprite to keep it simple. Our texture is just going to be whatever I can find in our assets. NPCs, Blue Patrol, this one. That seems like a good thing. Yeah. We can change the shape of the collider to make a little bit more sense. Maybe raise the sprite up a little bit. And there we go. That looks pretty good. So we're not actually going to be focusing a lot on the behavior of enemies right now, but we are going to be talking about how to spawn them into a scene. So I'm just going to save this in our prefabs. I'm going to name it enemy.tscn. So now that we have our prefab, typically the main thing you want to do with prefabs is put them in a scene. However, we want to continually spawn enemies into our scene and have the option of having no enemies at all. So we can't really just drag and drop it into the scene because that's just going to put 1. What we actually need to do is we need to make a spawner. And the actual node of our spawner really just needs to be a node 2D. So we can make maybe a new prefab here. It's going to be node 2D. And the reason I choose node 2D is because we can put a node 2D somewhere in space, and we can use that position to spawn all of the rest of the enemies. And all the enemies are going to spawn from that position and do something else or go somewhere else. So we just have our node 2D. We can save this as our enemy spawner in our prefabs and drag it into our main scene. Let's go into prefabs. Let's go into enemy. No, not the enemy. I don't want that at all. Cancel. I want enemy spawner. So we can just, click and drag this. Maybe we want them over here. And so this position, it's not going to show up in game, but that's where our enemies are going to spawn. So the actual interesting thing about this enemy spawner has to be added in a script. So we're going to go ahead and add a new script. We're going to do C# this time, and we're going to put it in our scripts directory. Enemy spawner.cs sounds like a perfect name.
So it's going to generate a C# solution I think it's the first time you add a C# script to your project.
Mm-hmm.
So
and we can make sure that it's actually built by clicking build. Hopefully this actually works.
Ooh, I really hope it works. Okay, cool.
It seems to work. All right. Yes, it's complaining at me, but I don't care. So this is our C# script. It's just like a GD script. So now we're just going to be creating our enemy spawner. So for our enemy spawner, one important thing for the enemy spawner to know is exactly what it is spawning. So we haven't done this before, but in script you can actually reference things that are in the assets. So you can reference other prefabs, you can reference other resources, anything like that. And the easiest way to do that is with something called so to access something that, access a prefab in this case, because the prefab is what we're going to be spawning, we want to export a new variable, and the name that Godot gives to scenes, which are prefabs that you can spawn, is packed scene. So we can just have a export packed scene, and we can name it enemy prefab, and save that. Go back into Godot and build. So now we have a little parameter, or not parameter, property here called enemy prefab, and we can actually load something into it. Let's go into prefabs, and we can actually just set this as our enemy. Open, and so now our enemy prefab is right there. We can click on it, and it's going to have some weird stuff in it. You don't have to worry about that. That's just what that is now. So now, in our script, we can access this enemy prefab and do whatever we want with it. So for now, let's just make our behavior that it spawns a enemy prefab when the game starts. And so let's just say that we have a function to do that, spawn enemy, and we call it in ready. Obviously we don't have that right now, but we can make it. It's just going to be void spawn enemy. So the actual process of spawning a prefab or a scene inside of a scene is called instantiation. So in order to instantiate this enemy prefab packed scene, you just call enemy prefab dot instantiate.
Instance.
Oh, instance. Oh, is it really?
Yeah.
Okay. Dot instance. I put this as a template in the notes. I don't know if it's actually a template.
I don't think so. The way I always do it is I just cast that to the type.
Anyway, I may have to update the notes, but this is what you do. So now spawn enemy calls the method instance on prefab, and it will spawn to the scene. So let's check that this does what we want it to. We go into main. We see that our enemy prefab is there. We have the script enemy spawner. Let's lay. And we can see that nothing happened. However, sneaky thing. I don't know if this will actually work. I don't think it does. No, it's not there. So, why did not work? Why did not work? So something we haven't really run into yet, but we're going to start running into as we want to do instantiation, is that you can have scenes and nodes that exist outside of the scene tree. That is, we have a scene tree in our scene, which is this hierarchy. So all of these nodes have a parent, and the root also has a parent, but that's not really visible here. But basically everything here is a parent, and it has a place in the hierarchy. However, when you just call instance on something, it just makes it exist, but it doesn't really give it a place in the world. It has no parent, it has no children maybe. Well, if it's seen, it does have children, but it's not in the active scene tree. So what you need to do to actually get it in the scene tree is you need to add it as a child of something. So we're just going to add child, but we need a node to actually use. We're going to use the return of instance, because it returns the actual node that it spawns. So enemy is this. And we can just give it enemy, and it will add it as a child of this node, that is the enemy spawner node. I think I also had this as a template. I don't think that's actually necessarily a template. I just did it to be safe, but I made incorrect assumptions. Anyway, you don't actually have to know the type of this. It's going to assign it node anyway. If you want to access the rigid body like functions that it has, you would have to cast it as a rigid body 2D. I thought this was required, but it is optional. Are you yelling at me? Oh. Hold on.
Capital
Oh, 2D. Capital D. So now enemy is a rigid body 2D. That's not necessary if you're just spawning it, but if you wanted to access, say, the velocity of this enemy, then you would have to cast it as what it is. If this was a custom class, say you had a custom class called enemy, you could also cast it as that. So we could cast it as enemy. We don't actually have an enemy class, but if you did, if you cast it to that, then you could access your custom methods and parameters and everything.
And this is only in C#. In GD script, you don't have to cast it unless you're being really specific about static typing.
Mm-hmm. Yeah, you can do it in static typing, but it's not necessary. So now that we have add child after our instance, we can run and we can see that we have a little enemy over here. Hooray! If we look in our remote scene, we have our node 2D. This is actually our spawner. And under it, we have a rigid body 2D, which is our enemy. We should probably name these, because having them be the default name isn't great. So let's just name this, it's really annoying, enemy spawner. And name this enemy. So now if we want to look at these in the scene tree, they will show up as that. This, however, needs to be renamed as well. Spawner. So now we have done that. So now we have the behavior of just spawning an enemy, but we want to have a little bit more interesting behavior. So maybe we want it to spawn enemies at an interval. So we can have something like a time interval. So we can say float interval. And this is going to be the amount of time that passes between spawning. So we're basically going to be spawning on a loop. And how frequent those spawns are will be determined by the interval. So if we build this, we have our interval. Let's say we want it to spawn on 1 second intervals. So we're just going to build a simple timer. There's a better way to do this with nodes, but this is basically how we're going to do it. So we also need another variable to keep track of, you know, the time between. So we can have float time. You can say it's 0 for now. And in our process, let's get rid of these. Actually, no, if there's a better way to do this. In our process, we are basically going to say time plus equals delta. So what this means is that time is going to be basically a counter in seconds since, like, you know, the node started. So it's going to start at 0, and every frame it's going to add delta, which is the time between frames. So over time, that's going to, you know, count to 1, 2, 3 in real time. So we can say that if our time is greater than or equal to the interval, that is to say, if the interval seconds have passed, then we want to spawn enemy. Enemy. Typing is hard. And then we also want to reset the time in the event that it has gone over. Time equals 0. So that looks pretty good. So let's go ahead and look in game what that does. So now every second, this is going to get weird quickly, but every second we have an enemy spawning. And it's basically just spawning a bunch of physics objects together, and they're going to make a big pile. So that's not good. What if we wanted to limit how many we had on screen? Then you need to keep track of a couple more things. Then you would need to say, we have another property called export max enemies. That's not the right case. So now this is another thing that we want to set in the editor. So let's say we wanted a maximum of 3 enemies. So now our logic would be, in our spawn enemy, we're going to add 1 to another variable that we have called int current enemies. Probably did this slightly differently in the notes, but that's cool. So our current enemies is going to add 1. And we also want to check that we're not over our maximum enemies when we do our spawn loop. So we can say and, which is and, current enemies is less than max enemies. I think that works. So now, if we go back in here and play, we have a max enemies of 3, so we should expect that 3 will spawn, and no more. So, the question is, did I do anything more advanced in the notes? Let's see. No, I think that's exactly what I did. All right, cool. All right, is there any questions about our enemy spawner? Obviously, now that we have our enemy spawner, you would want to add some behavior to our enemy here, maybe have it go left or right. You might also want it to be a character. That is to say, it won't tip over. So if we set that back to character, then now we're just going to have a stack, and they're not going to wibble or wobble. There's a ton of things you could do with the behavior. You could get the position of the player and go towards it, all that stuff. But is there any questions about that? Do you have any questions? Do you have any questions? Good, because I wasn't going to answer them. So, that is it for the enemy thing. Did you want to do the Singleton thing?
Sure.
Cool.
Let me pull up the notes. Oops.
So I guess I could start talking
Yeah,
about it.
you can start talking about it.
So, when I mentioned before that you don't necessarily need to have things in the scene tree, when they're outside the scene tree, they're inactive. But you can have something that isn't part of the current scene that is still active. And the reason for that is because the current scene isn't actually the root. There's a node above the scene root. It's called root, and it is a viewport. There's some implications to that, but you can look up viewport if you're interested in what that is. But if you run the game and go into the remote, you might see that above the current scene root, there is something called root. And that is a node, just like anything else. And the scene is, a child of that. So when we talk about singletons, we basically just mean a single object of a class, and there's only ever going to be one object of this class. And the object is going to be accessible globally. That means in any script, it just takes the name of the class to access its methods and its properties. And yeah, so the way that you actually add a singleton is you add a script, so we should probably add a script.
Are we going to make it a node or just a script?
Yeah, so most, all scripts basically need to inherit from something. I mean, not necessarily always, but to be an object, it has to inherit something. So most singletons inherit node. And node is just like kind of the base for all other nodes. And when you make a singleton node, it's going to make an object of that node and put it as a child of the root. So for our singleton example, we're going to be making something that will keep track of the let's say the amount of times that we restart a scene. So we can maybe call it the scene manager. A lot of singletons are managers, so let's call it scene manager. You don't necessarily need to save it as a prefab. All you need to do is create a script for it, and then when you add it to the singletons, or as a singleton, you just point it to the script that you made. So we're going to make a script, call it scene manager. This can be in either GDScript or C#, obviously. And the actual way that you add it or tell Godot that you want a singleton is you go into project settings, auto load, and then you browse for your script.
Or your prefab.
Or your prefab.
I just made it a
I usually do
prefab.
script because I don't usually have anything to add as a prefab. But yeah, now whatever prefab or script that you added is going to be a singleton. If we launch the game, we can see that as a sister node to scene, which is our scene root, we have scene manager. And anything that is, not necessarily, but for the most part, anything that is a sister node to the scene root is going to be a singleton. So for C#, you have to do some very interesting things.
I can talk about
you
this
can talk about this.
So in GDScript, it's very easy because you can literally just reference your singletons by name. So I could just say scene manager dot whatever, and it would work. But in C#, you have to do a bit more trickery, and this is actually pretty similar to how you would do this in Unity. So basically what we're gonna do is make a static reference to our single instance of this node, and we're gonna call methods on it that are static, so we can reference them from any instance of the class. So what I'm gonna do in here is I'm going to make a static instance of Scene Manager, and I'm just gonna call it Singleton. So that is going to be how we access this instance. So what we're gonna do is we're gonna make a constructor for our scene manager, and in here we're going to set our singleton equal to this specific instance of our scene manager. And I believe there's usually an extra safeguard you put in here to make sure you're not instantiating more than one, but normally that usually won't happen, but if you're careful, although I should probably do that anyway.
Yeah,
so
you would probably do it if you're using the class for things other than a singleton, like you have a singleton and objects of the class, but
I think this way will work.
usually Godot is gonna only ever create one.
So this basically says, wait, no, got it backwards. So our singleton reference starts off as null. So in our constructor, we're saying if our reference is null, then we're gonna set it equal to this singleton. Otherwise, we're gonna destroy this instance of it. So this will make sure we only have one instance of it ever active at a time. And let's just make sure that works real quick. Yep, okay. So now, because this is a static reference, or actually, so the way this comes in handy is if you want to access any specific members of this class, but normally what you want to do is make your functions static functions. So I'm just going to say, I don't think this is in the notes, but I'm just going to do it as an example. So now we have a static function called print something. And so what we can do is anywhere we want, we can just say scene manager dot print something. And that should just call that function. Yep.
So where this comes in handy is when we change scenes, or even restart the scene, all of the nodes in that scene, all of their members and data and parameters and everything get reset to their default values. So if you wanted to keep information between scene changes, say you wanted to maybe keep playing some music, maybe you wanted to keep the amount of times the scene has been restarted, anything like that, you would have to have something outside of the current scene, and singletons are outside the current scene. So we should just have some sort of static member.
There's a few ways you can do this. You can just have it, or yeah, let's just make it static. So we have this static member. So what we can, how did you do it in the notes? Oh, you didn't do it in the notes. Okay.
Well, I do talk about it, but I don't have the examples. So what we're going to do is we're basically going to have a static method that is going to restart the scene for us.
Yeah, that's how we did it.
And when we restart the scene, we're going to increment the number of restarts. And then we're going to have some node in the scene print how many restarts we've had. So the actual way to restart the scene in Godot is to get the tree.
And there's a caveat here. Because this is a static function, we don't actually have access to the tree. So we need to get our singleton, which is the specific instance, and that does have access to the tree. So we can do singleton dot get tree. So we want to get our tree, and then we want to reload current scene, I think. Yeah.
Even though that existed. So yeah, that's what you want. And then after or before that, you can just increment the number of restarts. So from one of maybe our player script needs to be able to restart the scene somehow. So
Oops.
maybe in process, just
This is in GD script.
that is in GD script. You can, well, this is a good example. So maybe edit that in the editor. Player.gd. So these are compatible with each other, GD script and C# singletons. I hope. So we would basically just say if the player presses the restart button, we can set that
have
up.
a restart button?
Don't think we do.
I don't
It's
think
not
so.
super difficult to set up.
Okay, so here
So we
can
would
just
check every frame whether the restart button was pressed. And then we would call the singletons single called scene manager dot restart scene, or whatever we called it.
Can you can't call it straight from GDScript.
No,
can
but
you?
you can call.
Oh yeah.
So GDScript doesn't know unless you just have to build.
Oh, maybe. Come on. No, I think you have to use call.
So GDScript and C# have they can't see each other's methods before the scene is built, but there is a way to call functions just by their string name, and so we can do that. We can just say scenemanager.call and then give it the name of the method. It's probably one reason why you don't want to mix C# and GDScript.
That's interesting.
That is interesting. But our scene can be restarted. Now we just need to print the number of restarts every ready on something like here. I guess we could also do it in the enemy spawner because it's there. So because this is in C#, it has knowledge of the scene manager.
Wait.
And we can just directly get its. Is it public?
No, it's not public.
Public.
Don't normally do this, but
So we can just directly print its number of restarts. And we're going to do that at the beginning. Did you save that?
yeah.
Okay.
I think. Yeah.
So now we have 0 in the output down there, 1 in the output down there. And so we are now effectively saving data between, you can fly, but we're effectively saving data between scene restarts. And that is a very integral thing in games. So it is very useful to know how to use singletons. Any questions on that? Any of the static stuff seem weird? You dealt with static things before?
I'm in ICS 46, so.
Okay, cool. So yeah, it's basically just a way to both be a node and have a static class.
Singletons get real fun if you use C++. There's all sorts of dumb stuff you have to do to get them to work, which we may talk about at some point.
Yeah. So I think we can just move on to audio. So I can do that.
Shall we switch again?
So, audio is pretty simple, and it works pretty similar to Unity if you're familiar with it. Go just back into the scene. We have 3 different nodes that are responsible for playing audio. We have an audio stream player. This is just, the default. We have another one in node 2D called audio stream player 2D, and another one called audio stream player 3D. So these are all basically have the same functionality. They can play sounds. You want to think of audio stream players as a single sound or a track of music, maybe. Basically one player per sound, and you can repeat the sound or change the sound that it plays, but generally it is one sound per audio stream player. So when you would want to use audio stream player versus a 2D or 3D audio stream player is the audio stream player without any position is just going to always play. It doesn't care where the player is, where the listener is, the camera, or whatever. Please, no. It's just going to play, and we can actually probably spawn one in so we can look at it. It just has a volume that it's going to play at. It has the actual stream, which is the sound that it's going to play, You can load it. I don't think we have any sounds, but you can load OGGs, I think MP3s as well, and so on. So that is really good for things that, you know, you don't care about the position. So a lot of times it's just the music is going to be in an audio stream player, or other kind of effects that you don't want to be positional. But any other positional noises, like sound effects, footsteps, sword attacks or whatever, all of those probably want to be a audio stream player 2D or 3D. Spawn one in right here. You can see that it has a position. Actually change its position. And so this is going to play sound relative to the listener, which I believe is the camera. So it has a couple more options here. It has, you know, volume and everything, but it also has attenuation, which deals with how quiet it gets at what distance, the maximum distance, and I didn't talk about this in the notes, but all audio stream players also have a bus, and you can manage this bus down here in the audio tab, and this is a way to manage the volume of one certain type of noise. So you can implement audio sliders with this, so you can have an audio bus for music, audio bus for sound effects, and then an audio bus for master. And then you can individually change the volume of all of the sound effects, all of the music and everything like that all at once. Otherwise you would be changing the volume on every single instance, which is not fun and something we definitely didn't do in base 6. So yeah. Otherwise, they're pretty simple to manipulate. So let's just say in our Singleton we have a Prefabs?
Yeah.
Scene manager. In our Singleton, we wanted to have a music track that would play continually throughout the scene changes. We would have an audio stream player as a child. We don't have any audio streams. Maybe I could record one. We have a little time. So I can just record something really quick. Microphone, Yeti, that's fine. This is a recording. It's going to be the music in our game and stuff. I don't know if we're going to be able to hear this, but hopefully. So we're just going to save that.
Export.
You want to export as OGG, because it's way better than MP3. Quality is 5 is fine. We're just going to, where is this on the desktop? Where is this located?
I have no idea. It's called Godot Workshop Project, I think.
Let's see if it's in documents.
There we go.
Workshop
Is it-
1 Godot.
No, it's at the top.
Godot Workshop Project. So we're just going to put it in assets. Here's fine. I'm going to call it cool music. .ogg. Audacity is really cool. I would recommend you use it. You don't have to save. So now we have a new asset. It's called coolmusic.ogg. So we would just set that as our stream, and we would be good. So in our Singleton, in our ready function, this isn't static, so we don't need to get the Singleton. We just have it automatically. So we could say audio equals get node. I believe this is actually a template.
Yes.
Audio stream player. And then we would get audio stream player, because that's what I named it. And we would have audio. So, I mean, this isn't something you necessarily need to do, but to just say the functionality, we can say audio dot play. We can also set here. This is a really bad thing to do. You should probably edit this on the node itself, but just to see that we can do this, audio dot repeat. Is that a?
Do you want it to loop?
Yeah.
That
it's
is
just called.
an import option.
Oh, is that really?
Yeah.
I had no idea. So, in our audio stream player import, loop is on. Loop offset, you can set that to say if it does loop, you can loop it at a specific point in the song in seconds. Also, this play has an optional parameter. You can give it a float. So if we wanted to play 17 seconds in at the beginning, we could just do that. We're not going to do that. So we are just going to play. Hopefully that doesn't break. This is a recording. It's going to be the music in our game and stuff.
Desk music.
This is the wrong scene. So let's get the scene here. This is a recording. It's going to be the music in restart our game and stuff as much as we want. And the audio, hopefully, this is just continue to play. It's going to be the music in our game. So that's how you would do the music in a game. Does that make sense? Any other questions? Otherwise, that's basically it. We finished right on time. Cool beans.
What are we doing next week?
What are we doing next week? It's not in the notes.
UI.
We can do UI. What would y'all wanna see next week?
I guess UI is fine.
UI is fine.
Okay.
Well, we might think of something.
I am absolutely not an expert on UI.
Yeah,
so
UI
that's
is
going to be your workshop.
Yeah, we can probably do an entire workshop on UI, because look at this control node. Look at this cool, like, let's say it's a panel or something. It's not a panel, but, you know, we can have all these cool anchors. It's, you know, make it 1, make it 0.5, and then the margin, set them to be 0 and 0, and it stretches and everything. UI is cool, but also really complicated. So, yeah, that is probably what we're going to do next week. Maybe we might think of other things, but yeah, that is about it.